Hello friends, welcome to Math Practice. Today we are going to discuss the first chapter of class 9, which is number systems. We are going to see the objective questions, some solved examples and assignment examples. So watch the video till the end and subscribe to Math Practice. Some standard sets in maths are set of natural numbers n, 1, 2, 3 and so on. Set of whole numbers means set of natural numbers including 0. Set of integers means negative numbers, 0 and positive numbers. Set of rational numbers means any number which you can express in the form of p by q. Set of irrational numbers means a number which is not a rational number. Set of real numbers means the set of rational numbers union the set of irrational numbers. And in addition, you can also have the set of complex numbers. Before we go to the examples, some things to remember. A rational number can have a terminating or non-terminating but repeating decimal representation. Means if it is a rational number, the representation will be either terminating, and if it is non-terminating, then it will be repeating or recurring. Decimal representation of an irrational number will always be non-terminating and non-recurring. Negative of an irrational number is an irrational number. Sum of a rational and irrational number is always an irrational number. Product of a non-zero rational number and an irrational number will always be an irrational number. Root n will not be a rational number if n is not a perfect square. So, for root n to be a rational number, n should be a perfect square. For two distinct positive integers p and q, if pq is not a perfect square, then root pq is an irrational number lying between p and q. These things will be important while solving the examples. In the first part, we will see the objective questions of the type true or false. First one, every whole number is a rational number. This will always be true, correct? Every rational number is a whole number. This will be false. Why? Because you can have any type of rational number. For example, if I say 1 upon 2, it is a rational number, but it is not a whole number. Every rational number is an integer. Obviously, this is also false. Correct? Root 2 plus root 3 whole square is an irrational number. That is always true. Why? Because root 2 is irrational, root 3 is irrational. Addition of both of them is an irrational number, and because you are having the square of root 2 plus root 3 whole square, it will be 2 plus 3 plus 2 into root 2 root 3, which is root 6. It is an irrational number. But if you are having 2 minus root 2 into 2 plus root 2, what will it be? A square minus b square is equal to a minus b into a plus b. So it will be 4 minus 2, which is 2. So it will be a rational number. So the fifth statement is false. 2 plus root 2 is an irrational number. This is true. As I told you, root 2 is irrational. When you are adding a irrational number and a rational number, the result will be an irrational number. 2 root 2 is a rational number. This statement is also false. Why? Because root 2 is an irrational number. When you are multiplying root 2 by 2, it will be irrational number. Statement 8. 0.333 repeating is a rational number. This statement is true. Why? Because the decimal representation is over here non-terminating and repeating type. So it is a rational number. 10.0100100001 is a rational number. This statement is false. Why? Because the decimal representation is non-terminating but non-recurring also. So it will be an irrational number. 0 is a rational number, obviously true. 0 you can express as 0 by 2, 0 by 3 in any p by q form. 0.142857 bar is a rational number. This statement is true. Why? Because bar means these digits are repeated. So it is 0.142857, 142857. Again it is repeated. So it is non-terminating and repeating. So it will be a rational number. Next one, the product of two irrational numbers is always an irrational number. This is false. Why? Because suppose you take root 2, it is irrational. Again you take root 2. So product of root 2 and root 2 is 2, which is a rational number. So the product of two irrational numbers may or may not be an irrational number. Pi is an irrational number. This is true. Irrational numbers cannot be represented by points on number line. This statement is false. We will see further that it can be represented on the number line. We can also have objective questions of the following type in which we have to give examples. In the first case, find three rational numbers between -2/3 and 1/4. The best way is whenever you have to find between two numbers, you go on taking the average. Remember, you can get any other answer than this also. So first thing, the average between -2/3 and 1/4, which will give -5/24. Again, take the average between the first number -2/3 and -5/24. This gives -7/16. And then the average between last number 1/4 and -5/24, which is 1/48. So we have found these three numbers. Second case, give example of two irrational numbers whose quotient is a rational number. We know root 12 is an irrational number, root 3 is also an irrational number, but root 12 is actually 2 root 3. So when you divide it by root 3, you get it as 2. So the quotient is a rational number. Also, you can have two irrational numbers whose quotient is an irrational number. For example, 2 root 10 upon 2 root 2. So root 10 means root 2 root 5. So ultimately the quotient is root 5, which is an irrational number. Give an irrational and rational number between 2 and 2.5. Rational number is simple. When you are taking the average 2 and 2.5, the average is 2.25. Irrational number, as we know that suppose if you are having 2 and 2.5, when you take the square root of both of them, it is root 5, and root 5 is an irrational number. Suppose you have to give two irrational numbers between root 2 and root 3. Correct? Now again, as I told you, we had just seen and resolved before that suppose if you are having root of PQ, the root of PQ will be a rational number only if PQ is a perfect square. Correct? So here root 2 and root 3, that is root 6. So it is not a perfect square. So what we can do is we just have to apply the square root. So square root of root 2 into root 3 is 6 raised to 1/4. Similarly, again take the square root of 2 multiplied by 6 raised to 1/4 and the square root of that. So that will give you 2 raised to 1/4 into 6 raised to 1/8. So this will definitely be irrational numbers. Give one irrational number between rational numbers 0.2101 and 0.222 repeating. Again, as I am telling you, you can have any answers, but one way to find the answer to these type of question is, suppose the first number is 0.2101 and B is 0.222 repeating. Now if you just see, after decimal the first place is same in both A and B. For the second place, 1 is less than 2. So A will be less than B. Consider a number C such that you are having C as 0.22, then 01, 001 and so on. Correct? Now over here if you compare, in the second place 1 is less than 2. Correct? So A will always be less than C. That is clear. Now for comparing B and C, for B and C first two places are same, but in the third place you are having 0 less than 2. So C will be less than B. So C lies between A and B and it is an irrational number. Also you can have fill in the blanks type of questions. The decimal representation of -4/9 is, -4/9 if you do, you will be getting -0.4444, means it is repeating, 4 is repeating, so it is -0.4 bar. The number 8.0025 represented in P by Q form, you just have to divide by 10 raised to 4 or 10,000. So you will be getting 80025 divided by 10000. So when you cancel out, you will be getting the smallest form as 3201 upon 400. 1.27 bar in the form of P by Q is what? Correct? Now for these type of examples, I think we know that whenever you are having 2 digits in the bar, you have to divide by 99. If you are having 1 digit in the bar, you divide by 9 and so on. So 1.27 bar is 1 plus 0.27 bar, which is 1 plus 27 upon 99. So when you simplify it, you will be getting that as 14/11. The value of 0.23 bar plus 0.22 bar in decimal is 0.45 bar. You are just adding both the things. The number of consecutive zeros in 2 raised to 3 into 3 raised to 4 into 5 raised to 4 into 7 would be how much? Now remember, when you can have zeros, here you are having the prime factors 2 and 5. So when 2 and 5 are multiplied, only in those cases you will be having the last number as zeros. So 2 raised to 3 and 5 raised to 4. The minimum power is 3. So over here the number of consecutive zeros will be 3. Now some subjective questions. Locate root of 9.4 on the real number line. We know that we can always represent an irrational number on the number line. This is the procedure. Draw a line and mark a point A on it. Mark a point B on the line such that AB is equal to 9.4 centimeter. Correct? Mark a point C produced on AB such that BC is 1 unit. You can see in the diagram BC is 1. Find midpoint O of AC. You know how to find midpoint of any given line. Taking O as the center and OC is equal to OA as radius, draw a semicircle. It is very clear that OC and OA will be same and they will be radius, which will be equal to actually 5.2 units. Draw a line passing through B and perpendicular to OB such that it cuts the semicircle at D. Now taking B as the center and BD as the radius, draw an arc cutting OC produced at E. So this point E thus obtained will represent root of 9.4, obviously considering B as the origin. Example 2. Rationalize the denominator in 1 upon 7 plus 3 root 3. Always you have to multiply by the conjugate, multiply and divide. So 7 minus 3 root 3, multiply and divide by 7 minus 3 root 3. So what will you get? In the denominator you will be getting 49 minus 27. 7 square minus 9 into 3. Why? Because a square minus b square is a minus b into a plus b. So now your denominator has become 22. So you have rationalized the denominator. Third example, express 0.3 and 2 bar in the form of p by q. So this is, suppose if you are considering x as 0.3, 2 bar, it is 0.3, 2, 2, 2, 2, so on. Since it is the bar for only one digit, multiply by 10. So what 10x? 10x would be how much? 10x would be 3.2 bar. So that is 3 plus 0.2 bar. Just now we have seen that 0.2 bar we can write as 2 upon 9. So 10x would be equal to 29 upon 9, or x would be equal to 29 upon 90. Example 4. Prove that root 3 plus root 5 is an irrational number. Now suppose consider x as root 3 plus root 5. Suppose if it is rational, just square both the sides. So x square is equal to root 3 plus root 5 whole square. Simplifying you get x square minus 8 upon 2 is equal to root 15. But we had assumed that x is rational. So x square minus 8 by 2 will also be rational. So root 15 will also be rational. But this gives us a contradiction because root 15 is irrational. Hence our assumption that root 3 plus root 5 is rational was false, and hence root 3 plus root 5 is an irrational number. Based on the solved examples, these are some assignment examples. Draw root of 3.5 on the number line. Write 2 by 13 in decimal form. The answer is 0.153846 bar. Write 125.3 bar in the form of p by q. The answer is 376 by 3. Examine whether 2 plus root 2 whole square is rational. It is irrational. Prove that root 7 is an irrational number. We have covered different types of examples in number systems. In case of any query, write in the comment section. Please like and share the video and subscribe to the channel. Thank you.